तो एक बार मैं ये देखना भी चाहता हूँ। आपका नाम श्री चैतन्य है ना? Thank you so much, Sri Chaitanya. At the onset, I would like to thank Honorable Vice Chancellor of BTU Patnaik University of Technology, faculty members, student, organizers of this conclave, Transforming Technical Education in Odisha, officials of Shiksha Sanskriti Utthanyas for inviting me and for hosting me at this place. It's really an honor and privilege to be here to part of this conclave. I would also like to welcome all the participants, principals, directors of different institutes of Odisha. I welcome you all and I convey my pranam to all of you, all the participants, students of this conclave. Now, before I start my presentation, I would like to ask one question to all of you. Although you have been listening to presentations for last, maybe yesterday also you were listening and today also you have listened to one of the presentation, just think in your mind, if I ask you one question, what is the origin of science, from where the science and technology has originated? In your mind, if you are not listening to talks related to Indian knowledge system, in your mind, the answer to my question would be that science and technology have originated either in Greece or some European laboratory. So what we feel is, we always feel that technology and development of science has taken place in West. And if you talk about this East India, east of world or India, we feel that we were in darkness. But since you have been listening to talks related to Indian knowledge system, and you know the answer that no, we were not in darkness. A lot of things were there in this country also. So it is a wide belief that first phase of science broke in the West. However, it is not true. So in this talk today, I would be talking about history of science and technology in India, starting from way back to this era. And my talk would be concentrated on 4 questions. The 4 questions are, was there science and technology in India? And if there was science and technology in India, what were the scientific advancement, technological advancement in India? Where were we developed? So many things are there. Maybe in my talk of 30 to 45 minutes, I will not be able to cover everything, but I would give you a glimpse of a lot of advances in science and technology in India. Another 2 major questions which we would like to answer in this talk would be, what was the purpose of science and technology in India? And if the purpose was defined, then that science and technology which is being developed in India can solve the problems that are existing in world today. So there are many problems which are existing. Does our science has the capability or capacity to solve those problems? So at one time, Indian science and technology was very well developed, but a period came when people started to destroy the technological and scientific advancement of this country. I'll give you an example from where you can take a cue that in India, science and technology was developed to such an extent which is unbelievable. One example is, you see, after every 25 kilometers, the language changes. Such was the development of language in India that people, most of the languages are from Sanskrit, people use that as base language and they created their own languages. So many languages exist in India. This is unique. There is no country in the world which will have so many languages existing in a particular country. The other thing is, if we talk about cuisines, different variety of foods that are existing in India are enormous. And when we develop a new quality of food, new type of food, you must understand that behind that, there has been some experimentation. Somebody has thought about creating a new kind of cuisine. Even if we talk about a simple example of pickle, same mango pickle produced by people living in different parts of the country will be of different types. Behind that also science and technology is existing. So when a time came, people started to destroy what was already existing in India in terms of science and technology. Some of the scientists rose up. They thought, if we will not rise today, we will not be left with anything which was existing in India. And one of the problems of India is that whatever science and technology that has been developed was not well written. No documentation was available. And even if documentation was available, it was in vicinity and people tried to destroy the existing documentation of Indian science and technology. So at that time, scientists like Acharya P.C. Ray, he rose up to that occasion when in British era, he wrote a book. He was founder of Indian chemistry and author of the book, A History of Hindu Chemistry, wherein in 2 volumes, he wrote a lot of science and technological advances that had taken place in this country. He was also inventor of number of nitrites. At the same time, there was another person, Mr. Brijendranath Seal. He took a landmark survey and he wrote the positive science of the ancient Hindus. So they wanted to document which was being destroyed. They wanted to tell the people, yes, science and technology existed in India. And what was the motive behind this? See, if we do not know what our ancestors did, and if we do not know whether science and technology was actually developed in this country, then we are not confident. We are not confident to think that, yes, we also have the capacity to develop science and technology. We also are in position to contribute to science and technology. So we should know what was existing. You just think, if your friend, your classmate, your colleague is able to do something, then from inside, you also feel that, yes, if he or she can do, I also can do this. And therefore, it is very important to know that, yes, we also were developed. We also have our own history of science and technology. And that is what I am trying to tell you. Although you have been listening to such talks for the past 1 or 2 days, but still, I want to imbibe on your minds, yes, we also were developed. Then there was a scientist called Professor J.C. Bose. He did landmark development he was a pioneer of plant and wireless science. He was a scientist of world rank. He invented wireless communication long before Marconi did. He was pioneer. And when you would be surprised to know that when he was told that you should file a patent for this, he said, no, I will not file patent because science should be free for everybody. People want to have their name. He never wanted his name. He was the first person to tell that life existed in plants. Nobody before him did believe that plants also have life, biological systems also have life, but he was the person. But he never wanted his name and he never filed the patent. Then there are others, R.S. Weiss and others. These are the scholars who recovered India's technical and craft traditions. So these are the people who at that time when science and technology was being destroyed, they did something so that today we have something to know about what our ancestors did, how ancient science and technology in India was developed. So I would be talking about three movements, and the first is ancient foundation. I have not divided them into timelines, but I have divided them into domains. So first is ancient foundations. This is from era 3300 before Common Era to 1700 Common Era CE, and the domains that I would be talking about where Indian science and technology was developed are mathematics, astronomy, medicine, first domain, second is materials, metal and chemistry, third is water and movement, and the fourth domain would be seats of learning and medieval period. Then I would be talking about the modern India, which starts from British era up to this digital technology age. I would also be talking about the purpose behind knowledge. What is the purpose of science and technology? I would also be talking about whether we have answers for troubled world and how we can have Viksit Bharat. I would like to tell you that scientist P.C. Ray, like today we are talking about Make in India, he was also pioneer for Make in India concept, and at that time for Indian products, he had established Bengal Chemicals. So at that time also this thought was there to have Make in India concept. Now coming to mathematics, astronomy and medicine, the first engineers, if we talk about first engineers in the world, we already know. Although in our books, in school level, very little was taught about this. And as I told you, this technology and science which was developed in India was never being taught to us. And therefore we don't know how advanced our people were. So we talk about this Harappan civilization. This is the world's most sophisticated urban infrastructure of the world. It was planned to a standard that would not be matched today also. So very meticulously planned structure were there. Grid pattern streets were there. Zone districts were there. Citadels at Mohenjo-daro and Harappa were there. It was a engineering marvel. They had a sewage system, perfect sewage system, which was flowing through beneath every house of that civilization. The sewage system was a brick-lined sewage system. So they knew the technology of brick. They knew the technology of kiln, how much temperature has to be maintained, and from using clay, how brick can be manufactured. At that time, they were knowing that technology we are using till today also. The Great Bath, you already know, is a marvel. It is a watertight public reservoir built with precision laid bricks. Again, using bricks, they had made this great water bath. Lothal's tidal dockyard, and they had standardized weights. Standardization was also there. In construction also, there was standardization. Everything similar kind of structure was being built. So standardization was there in this. And they had covered urban drainage system. Now coming to mathematics. So the idea of zero, actually it started with Aryabhat. He did not give the name zero, he used dot to separate digits, but actually the idea of zero came from Brahmagupta. He was the first person to give insight of algebra, negative numbers, negative numerals. So he developed algebra and number system. Brahmagupta in 628 Common Era wrote the first rules for calculating with zero and negatives. Then geometry was actually built in the year 1800 BCE. That included Pythagoras theorem and the concept of square root. Then binary sequence and combinatorics described over 2000 years ago. That was all done in India. This is what we have to think about. And the people behind this, the minds behind this, Aryabhat, he calculated accurately the value of pi. He used sine tables that seeded trigonometry. Then we have Brahmagupta. He gave rules for zero, negatives, quadratic equation, and the differential calculus was based on this algebra. So that was the beginning of differential calculus also. Then we have Bhaskara. He gave earlier, he was the first person to give ideas about differential calculus. Then we had this Kerala School of Astronomy and Technology, Science. They gave infinite series for pi. They gave the value of sine and cosine, tangent inverse. Long before Leibniz or Newton gave the concept of the sine function, cos function, tangent inverse function, and their series expansion. So it was done well before that in India. This we must understand. Again, Aryabhat was the first person to tell that Earth is rotating on its own axis. He explained the concept of lunar and solar eclipses, how this happens. He was the first person to have told this. And then in Kerala, they had built a model with planets orbiting the sun. So planets were orbiting the sun was also told by Indians. And then the concept of gravity. Brahmagupta gave the concept of gravity, that bodies fall to earth as it is the nature of earth to attract them, long before Western scientists did this. Why we should know this? Again repeat, we should feel proud of what we did. We should feel confident that yes, we also can, and we also have a long history of scientific and technological developments. Then Ayurveda. and the beginning of surgery. We had two doctors, Charaka. He started the physician tradition to diagnose disease, to cure disease, to prevent a person from disease. Then Sushruta, he was good in surgical procedures. He could do surgeries, and he was the first person for rhinoplasty. So this is what, he was also the first person for doing cataract surgery. Now coming to materials, metal and chemistry. I already told you that they were kilns. People were knowing how to make bricks, but not only they were able to make bricks, they were able to make crucibles also. They had standardized the manufacturing of bricks. They controlled the kiln temperature, and clay chemistry was known to them. They knew Ayurvedic pharmacy, and they could make medicines from plants, herbs, metals, minerals with extraction, distillation, and fermentation. They could make ceramic from silica, lime, and alkali. They could produce dyes, and not only produce dyes, they were knowing how to fix the dye on cloth, how to fix the paint, dye on wall. You have Ajanta Ellora caves. The paintings are there for more than 1500 years. And the material by which they have fixed those dyes on those walls was so good that today also they are as it is. If it is not being destroyed by man, by themselves. They had the power to make perfumes, oils. They had beads. They had created beads also. So they had empirical methods. Although at that time it was documented, but later on it was destroyed. They could observe, they could repeat the experiment, and they could expertise. So developed was their technology. The science of mercury. Mercury is a metal. Science of mercury, sulfur, and minerals, turning metals into medicines through controlled, repeatable processes. Purification of mercury, incineration of mercury, digestion. Here the word digestion means that to remove toxicity by grinding the mercury, by mixing the mercury with herbs. Again, trituration is also removing the toxicity of mercury and to make it suitable as a medicine. So they had the power to convert these metals and minerals into medicine. They were the first person, Indians, who could So this demanded sublimation, calcination, roasting, distillation. This was chemistry of a remarkable sophistication at that age. We were developed to that extent. Now if we talk about metal, the iron pillar of Delhi, it is standing there. 98% of this is wrought iron, and without rusting it is standing there for years together, more than 1600 years that it has been standing. Wood steel, the best steel at that time, it came in 300 before Common Era. Zinc at Zawar mines in Udaipur. They could distill zinc. Zinc is a peculiar kind of metal which boils before melting. It starts to boil before melting. So distillation of such a metal zinc was very difficult, but they could do at that time. And it was the earliest on this earth. Then there were lost wax masters. Yesterday also you were listening. We had this temple icons, and we also had this dancing girl that was made using lost wax technique at different places at different times using the same technology. So that tradition was continuing, and today also we are using this technology. We have, at that time we had precise alloy composition and complex temperature control, chemical patination, oxidation, and sulfide finishes for the color, bronze that is simultaneously sacred art and metallurgical feat. Knowledge was being transmitted from one place to another. Gold and silver coins in Mauryan and Gupta dynasty was there, which required refining, alloying, casting, and embossing. Coins were being produced at that time. Then we had this chemistry of color, and these were natural colors. Using turmeric, they could make brilliant yellow, which was used in textiles, cosmetics, and for ritual purposes. They had madder for making red color, crimsons for fabric, leather, and paint. They had used indigo for making blue color. India led the world for centuries in this indigo color. And then, as I told you, they had the capacity for this fixing these dyes, modern chemistry, which was an example of breakthrough in science and technology. I will have to move faster because time is short. Water. In India, water was conserved. Rain water was harvested. It was kept there, used for irrigation. We could store, we could distribute, and we could sustain. We could increase the groundwater level. We had ponds, we had pools, we had ponds, we had step wells, where the evaporation was reduced, water evaporation was reduced, groundwater was increased, groundwater level was increased. They could filter the water. So filtering of water was there. We were very much developed. Today also we feel that water should be conserved, rainwater should be harvested, and groundwater level should be increased. Harappa was the first sanitary city. Dholavira, a water city in Kutch desert, which has number of reservoirs cut into rock. They have check dams, stormwater channels for distributing the water. They could harvest the rainwater. We had these bawdis, step wells, kunds. You must have seen Rani ki Vav step well photo on 100 rupee note. This is there in Gujarat at that time. And from there, these step wells started in Gujarat, and from there they were transferred on to other cities of country. They went into Rajasthan, Madhya Pradesh, and so on, so on. And there were a number of check dams, talabs, etc. And when we talk about transportation system, we had at that time on Harappan streets right angle grid for car traffic. We had spoked wheel chariots, axle-based bullock carts at that time. Roads were developed, Mauryan highways with shaded trees, wells and rest houses. So developed was the road infrastructure at that time. Then we have Grand Trunk Road. We had navigation over water, ships. Then we talk about seats of learning, Nalanda. It was an example of best type of multidisciplinary university, residential university. And you would be surprised to know that at that time when Nalanda was being destroyed and when they burnt the library of Nalanda, the library continued to burn for several hours. So many books and so much of literature was there in Nalanda library. There were more than 10,000 students, 2,000 teachers and scholars, and it was a 9-storied building. Then Takshila and other such institution of learning. My time is okay. So I'll just now come to my last part of my. If we talk about modern India, Bhabha established atomic centers. Vikram Sarabhai is the pioneer of space technology. Shanti Sarup Bhatnagar established CSIR labs. We had IITs. But you must understand, after so many of years of existence of these labs, IITs, what was happening was IITs were limited, only 5 IITs were there. CSIR lab was there, but whatever they were doing was there inside. No technology transfer was being taking place. From IITs, brain drainage was taking place. Now the time has come where we have so many IITs and students graduating from IIT can contribute for the development of this country. These IITs at that time I think, were developed to train the manpower at low cost, bring to the Western countries for working for those countries. Now things have started to change. Technology is being transferred in CSIR labs and so on and so on. We will not talk about these things. I have limited time. Today we have Aadhaar. UPI is the best example of technology in India. We have these service and software industry developing in India. During the COVID time, the medicine, the vaccine developed in India saved so many lives throughout the world. We have this Aadhaar, UPI, Indian stack. We have these vaccines and so on, semiconductors, clean energy. Now, I would come to purpose behind the knowledge. India has the concept of Sarve Bhavantu Sukhina, welfare of all, harmony with nature, guided by ethics, the pursuit of truth, material and spiritual knowledge. So, spirituality, science, and technology, they are integrated together. This is there in India only. Nowhere in the world do we have spirituality integrated with science and technology. When we develop something, we always in our mind have that it should be sustainable, it should be for welfare of everybody, it should not cause harm to anybody, and it should contribute towards the development and welfare of society. This is the concept. We work on the concept of Bahujan Hitaya. We have medicine for making people healthy. We have yoga. without giving any medicine, we want to make people healthy. This is the concept that we have. And coming to last part of my talk, we talk about dharma, we have satya in mind, we tell people to find out the truth. Just do not believe when I say or somebody says something. Try to find out the truth. This is what we have. And the last question is, why the purpose behind the knowledge? The purpose behind the knowledge. Answers to troubled world. Yes, we have answers to troubled world because our science and technology is sustainable. We live within the nature's limit. We do not want to destroy nature. We have technology with ethics, and we have knowledge as common good. So this is the difference of science and technology that is being developed in India. People, because we are talking about transforming technical education in Odisha, the student must know this. They will be encouraged to contribute to development of science and technology. They would learn from what was there in ancient India. They will feel proud about India. So it is a must that we should include all these things in the curriculum. In our Bikaner Technical University, we have introduced a 2-credit compulsory course on Indian knowledge system, and specific to the domain. Electrical engineer will learn some basic Indian knowledge system and the Indian knowledge system related to electrical engineering, similar for mechanical engineering, similar for management studies. Everywhere we have introduced a 2-credit compulsory course for Indian knowledge system. Because my time is over, this is what I could tell you in 30-35 minutes that had been given to me. I must again thank the organizers for inviting me to this place, for giving me this opportunity to interact with you. And now I am open for the question. Thank you so much. So no questions? Thank you so much once again. थोड़ा सा फास्ट किया, मेरे पास टाइम कम था.
Thank you very much, sir, for your enlightening and thought-provoking session. So your talk beautifully reminded us that India's scientific and technological journey has very deep roots. Your session has helped us realize that modern technical education becomes more meaningful when it is connected with our own scientific traditions, mathematical wisdom, and civilizational knowledge. This is very much aligned with the vision of NAP 2020, which encourages the integration of Indian knowledge systems with contemporary education and innovation. Once again, on behalf of BPUT Odisha, I sincerely thank you, sir, for your valuable presence, guidance, and inspiring talk. So please join me in expressing your heartfelt appreciation to Professor Akhil Ranjan Garg, sir, with a big round of applause. So with this, we conclude this morning session. I sincerely thank our distinguished speakers, respected dignitaries on the dais, off the dais, faculty members, organizers, volunteers, and all the participants for your active participation and cooperation. We will now break for a tea. Kindly reassemble here after tea break, which will start at 11:30 p.m. the next session. Thank you.